Hi everyone, today I wanted to go over some of the freeform surface modeling techniques that people are having difficulties with, and the way that I thought might be best to kind of demonstrate some of these is to go over some of the examples, some of the real world building examples, and I kind of picked a couple of examples, and what I'll try to do is model some of the kind of overall geometry to demonstrate how it is possible to achieve similar types of effects in your design projects. And of course we'll be using Rhino for this to kind of model surfaces as NURBS, freeform surfaces. And the first example that I wanted to look at is Gehry's building in Sydney. And this is kind of what it looks like. So essentially it's inside of a rectangular frame. It has a lot of curved surfaces that are clad in brick, and the protrusions are made to kind of articulate these apertures. And I just wanted to kind of focus on one of its elements. Let's say I'm just going to pick one of these walls and just show you some of the tools that we have available to us inside Rhino to be able to kind of recreate it. What was the wall that I was looking at just then? This wall here. Okay, so I'm just going to keep this as a reference. And go back into Rhino here, and I'm going to go into the front viewport. And so this is one of the methods that you can use, and this method basically involves kind of taking slices through the shape along its length and modeling them as NURBS curves. So for instance, I may take the first where the wall kind of begins and model that as if it was a elevation looking at it from the side. So I might model something like this, and these are going to be fairly rough, just to kind of demonstrate the idea. So this is the first curve, which is here. Then I'm going to kind of imagine a curve cutting through a different part of the building, and I'll try to kind of make sure that the first point aligns with itself, and then I'll try to kind of model this. There's a kind of kink coming out of this building here, and that's what this is supposed to be. And then I'll take another curve that's hypothetically cuts through here, and it might be inset a little bit. Maybe something like this. And finally we have our last curve that I'm just going to make sort of very similar to the one that we had here. Just going to make sure that that all of the points at the beginning of the curve and the end of the curve kind of align with all the other points of all the other curves. I'm just going to make sure that that happens. So now what I'm going to do, I'm going to go into perspective viewport and kind of drag these out so they kind of spatially correspond to each other. Something like this. Maybe maximize this a little bit, space them out a little bit more. And then what I'm going to do is I'm going to interpolate a NURBS surface through all these curves using a loft command. So once I run this command, it's going to present me with some options. And so this dialog box basically gives you some of the parameters that are guiding the construction of this loft, and I'm going to change this. So by default it was set to loose, and that basically means of how close the surface is interpolated through this curve. So if I choose normal, it should interpolate it a little bit more accurately. I may want to probably move this curve a little bit closer. I can cancel this and try to do this differently to kind of accentuate this bulge a little bit more. Something like this. In fact, what I might do is I might space these out a little bit more so it has a bit more. And again, you can right click to repeat the command. And I think this is good enough. And this kind of process, you know, approximates what actually happens in this type of method that Gehry utilizes, because essentially what happens is he constructs these paper models, and then they're scanned with 3D tools. So essentially, when you bring it into the computer, what you end up with is a bunch of these kinds of points that so a bunch of points where the kind of scanning tools scan the paper model, and then they need to be kind of resolved into a surface or a mesh, either using modeling tools or algorithms to kind of achieve that. So we kind of did it sort of by eye and created this kind of surface. Another way of, so essentially what we did is we imagined kind of 4 sections through the surface and then interpolated them using the loft command. Another thing you can do is draw curves that correspond to the edges of this surface. So instead of drawing them, I'm just going to duplicate edges using dup edge command, because I can do that once I have this surface. So this is kind of like an alternative method. So you can actually draw these curves approximating to, like, let's say you're working on a precedent, or whether it's your design project. And then there's a command called network surface that basically creates a interpolated NURBS surface through reference curves. So if you reference 4 curves, or you reference curves in a sequence, if you want to learn more about it, you can use the help tab to give you more information about it as you're running the command. And there are useful tips and different options for this command that you can access also. And that gives us this type of surface, very similar because it's been constructed with kind of very similar tools. And that's just another way of kind of dealing with this free-form surface type scenario. I'm just going to delete these. Another thing that you can do is you can offset this surface to give it some thickness. So once you run offset srf, you get these white lines, which you can then change the direction of with these options. You can change whether the shape is a solid, or whether you simply want the surface to be offset. You can change, you know, which kinds of corners you want, the distance of offsetting. So at the moment, if I offset it, it'll be very, very thin. So I need to bump up the distance of this offsetting. I'm not actually modeling to scale or anything, but just as a kind of case in point demonstration. So that's how you add kind of thicknesses. Again, offsetting kind of offsets it in all directions corresponding to UV vectors on that surface. So it'll be offsetting it in the direction essentially perpendicular to every point on the surface. So this is why you sort of get not simply an extrusion, but a true offset. So you know, the perpendicular kind of vector on this point will be facing this way, on this point it'll be facing that way, and here it'll be facing this way. So this is why you don't get a kind of extrusion. Additionally, you can use extrude surface command, in which case the you will need to pick the direction of extrusion, and this will essentially vary the offset. So let's say the thickness here will be less than thickness, let's say here, and here will be less than thickness here. But as you can see, it all kind of extrudes in one direction. So that's kind of another method. To form corners, we will need to use kind of trimming operations. So again, if we look at this example here, there's different kind of conditions of corners in this building. So what would be a good, so let's say this image here. So you can see that, let's not go on this website. So you kind of can see here that where the brick wall turns, the corner is more or less straight. And as we've seen in that wall example, here it turns into kind of this curtain wall condition, where the curtain wall itself is flat and it's kind of trimmed off by this surface here. So and this kind of prevents this building from becoming too free-form around its edges. So if you look at this edge, it's more or less kind of rectangular, and all of the kind of free-form disturbances in the surface happens inside. Again, so we can kind of simulate this by trim operations. So we can construct a vertical plane surface, for instance, like so, and we can trim this surface against this surface to kind of simulate this kind of curtain wall effect. Or if we want an edge between two freeform surfaces, we can, I'm just going to cheat and rotate this while copying it. So I'm going to rotate it 90 degrees like this, and then I'm going to move it until it kind of intersects with this. And then I'm just going to trim these two shapes against one another until I get this kind of free-form edge of this surface. And this is kind of a technique for intersecting these free-form surfaces and actually forming corners to enclose your volumes. So that's basically, that's a basic technique for constructing these types of geometries. And hopefully this was clear enough. Now moving on to the next example, we have this type of condition. So this is a Guangzhou opera house by Zaha Hadid, and if you have a look, it has this kind of crystalline, not exactly free form kind of surfaces, but kind of crystalline surfaces with a lot of flat surfaces and chamfered edges. So how would you go about doing this? Well, not necessarily the exact way they did it, but you could kind of approximate this by the following method. So what I'm going to do is I'm going to basically construct a 3-point box. Additionally, what you could do is you can type in box and then type in 3, and that allows you to draw a box from 3 reference points. So this will serve as a volume, which I then going to be cutting bits from. So you can kind of, so it's a kind of subtractive method of modeling by which I have this overall volume, and then I'm going to be kind of slicing through it. And the way I'm going to be slicing through it is I'm going to be using the rectangular plane 3-point tool. So when I click on that, it kind of asks me for 3 points that I want to reference to construct a plane like this, right? So I picked point here, and then the point which determines which way the plane is oriented. And then I can use this point to essentially trim this volume, and then I can trim the surface against this volume to create this surface here. One thing to watch out for when you do that, you actually end up with one poly surface and one single surface. So what you need to do is select both and kind of join them together to form one close poly surface. And another thing you can do is when you're creating these kinds of things, and again I can snap to kind of any point on this object. I believe there's a tool, and I'm kind of going into unknown territory here. There is a tool. I think there it was, called Create Solid. So essentially, what it's supposed to do is when you select a bunch of surfaces, it tries to approximate the object that you're trying to model, and there you go. So essentially what it did is, so I had a plane here. It's part of the Boolean commands. So what it does in this instance, if you select both of them and select this command, it kind of gets rid of that surface that I had and basically splits the shape in two based on where that plane cut it through. So I guess it's a much more efficient way than kind of doing this, like first constructing this surface and then trying to trim it, because what we need to do is when we run the trim command, we need to first of all cut this object by selecting this surface as a trimming surface, then cutting out this corner. But now once we run this command, we end up with a hole and a surface. So now what we need to do is to run the trimming command again, select this shape as a trimming shape, and then trim out this surface until we get left with this triangle. So now we have these two shapes, two separate shapes that we need to join together. So we have to kind of do a join operation and join them together. So these are kind of a significant amount of steps when you can simply kind of run your surface. So this is 1, and then select all of them, that's 2, and then just simply get rid of this surface here, and that's 3. And in this particular case, what you can see is we basically keep going with this kind of method until the overall form becomes less kind of indicative of the rectilinear form that we started with. And again, sometimes you might run into this problem. So for instance, when I draw a rectangle and I want to trim it against this form, it's not going to work because this plane is not fully intersecting this volume. So if I run trim operation, it's like cutting objects and I try to trim that, it's not going to work, right? Because this plane is not fully trimming. So what you have to do is either move it until it fully intersects, or scale it in all directions until it becomes big enough that it intersects this volume fully. So you can actually see here that intersect. The way to check this is if you run intersect command like this, and then you select these two volumes, and that's going to produce the curve that intersects those two objects. And if the curve is closed, that means the trimming operation will work. But however, if we have this kind of condition and we run intersect, the curve is not going to be closed, in which case the trim command will not work. So you kind of have to, either scale or redraw the or move it around. So for instance, if I wanted to shift it, I'm going to have to pick, in order to overlap the shape, I'm going to pick one of the points on either this edge or this edge and kind of move it in relation to its own edge like this. And now I can run this command and get rid of this. So you can kind of begin forming this kind of crystalline form. Again, just remember this, that when you're forming these planes, It's very, very important to make them intersect the shape that you want to trim them against. So just remember the scaling thing is kind of important. You kind of move it around until it fully intersects the shape. Something like this. So once we kind of have our crystalline form that we're happy with, what we can do is now we need to kind of chamfer these edges. And the way we do this is by using the command, sorry, not chamfer, fillet. We need to fillet these edges. The difference between chamfering and filleting is chamfering basically cuts kind of a flat, creates another flat surface. Filleting actually creates a round edge. So if we go fillet edge, so it asks us to select edges to fillet. So if we select one edge, it's going to tell us the kind of geometry on both sides of that edge. And then if we run this command, what you're going to notice is it created a fillet like this. So the fillet size corresponds to these numbers that you see when you first run this this command. So 1 is kind of 1 unit inside your modeling space. And then again, we can select all of these edges and run fillets on all of them. And what you can see is when they intersect, it kind of forms these patches here to kind of take into account that there are multiple fillets going inside one another. And that's essentially how you create these types of volumes. And again, you can modify this here. You can change the radius of these fillets. However, one thing to kind of take into account, select radius, so I can do it at 2. So this one is it at 2? Let's do this again. No, it's still at 1. Select fillets, add, put on same. No, that doesn't do it. Let's see here. Interesting. Okay, so next radius. Okay, so you have to click the next radius to actually determine what the radius of it is. And if I click on 3, it should make it significantly bigger. Yeah, there we go. I would hold off on making it too big, because if it gets too big, and I'm going to demonstrate it now, what you will actually end up with is some very weird intersections. So this happens because the radius of these fillets is too big, so when they come to intersection, they can actually form patches, and this is what happens. So just make sure when you're filleting, it's kind of either reduce the size of the fillet, or alternatively get rid of these very short edges that prevent them from kind of forming independent fillets. So that's my advice. Okay, so moving on to the last example that I wanted to talk about, and this one is a little bit tricky because of its very strange geometry. So this is Cooper Union, the new Cooper Union building in New York, by Thom Mayne and his design studio Morphosis. And as you can see, it's a kind of rectilinear volume which kind of does interesting things. On one side, it's a kind of concave kind of shape penetrated by this aperture, which is kind of an unusual shape, and then at the top here it has this kind of crinkling effect, So you can kind of see it from these shots here where the surface is actually kind of curving in. Maybe view it from here, yeah. So when approaching kind of modeling these types of things, it's kind of important to contextualize it and view these as surfaces, and how you may be able to construct it. And also break them down into simpler kind of shapes. That also helps. So let's say if we wanted to model this type of geometry, the way I would approach it is I would first form this bottom surface. And as you can see, what you try to do is you try to rationalize in terms of how can this surface be formed from curves, and what kind of curves would I need to create this surface. So in this particular case, you can see that this edge is curved in, and this edge is completely straight. So it goes from straight edge, shown from this shot here, completely straight, to a kind of filleted curve here. So it's a similar kind of process that we've seen in the Gehry example, except this one is much more rationalized. So the way we could do this, I'm just going to get rid of this and go into front view, is we can draw a kind of straight line like this, and then just looking at this example, just going to bring this up like this, minimize this. Okay, and on this side, what we could do is we're going to form like a chamfered volume. So we're going to kind of make one curve like this, then mirror it over to the other side using the middle of this straight curve like this. And then we are going to, I keep on saying chamfering, but it's actually fillet. So just watch out for that. I keep on mixing them up. Works. Fillet, unlike fillet edge, fillet actually is used only for the two-dimensional or three-dimensional curves, not actual edges of three-dimensional objects. And then we get to select two curves, and then it automatically kind of fillets them. In this case, the fillet's probably too small. So what I'm going to do is kind of bump it up a little bit, probably to 5. And it's probably too small again. Bump it up to 7. So 7 indicates the radius of this curve that completes this object. So I think I'm gonna go with 10 actually, because it seems like it's a kind of very pronounced curvature that's going on here. Maybe even bigger actually. Something like 15 maybe even. Yeah, I'm okay with that. And then just join these things together. And now if we go into perspective viewport, we're going to do the exact thing that we did with the Gehry example. I'm going to move this a little bit further out like this, just give us enough space. And then we're going to loft them together, something like this. Just going to make sure that everything is okay with this shape. It's a kind of very unusual geometry that results from lofting these two curves. So as you can see on one side, now we have a kind of very straight edge like this, and on the other side we end up with a curved shape, and in between there's a kind of change in geometry that goes from kind of a flat surface to a doubly curved surface like that. Okay, so next thing is we have a kind of crinkling of geometry here at the top of this building, and one of the methods to kind of tackle this is it's always good to kind of look at many references just to see what exactly is taking place. See, maybe this is a good example. So obviously this surface is being trimmed off, and then a new flat surface is going up, then it crinkles, and then another flat surface is being kind of erected here as well. So these are all flat surfaces, they just angled at different, well, they appear to be flat, and they're most likely to be flat. So just trying to find some good images of that crinkled profile. There you go. Okay, so that's probably the best we would be able to do. So the first edge, and this edge appears to be straight, right? However, if we were to say draw this edge here, you'll notice that it doesn't fully intersect this surface. So if we do intersect, we see that it only intersects at these points, and the curve doesn't actually touch the surface. So that becomes a bit of a problem. What we need to do, preferably, is to actually reconstruct this surface so this edge can become straight. And the way we're going to do that is kind of duplicate edges like so. Actually get rid of this surface. Rationalize this so we can trim this against this. So we end up with a kind of something like this. And then we can just run network surface. Okay, asking me to select these curves again. Oh, I see there's some duplicates. Let me just get rid of duplicate curves. No duplicates? Clearly there are duplicates. I'm just going to manually clear them out. Run network surface on that again. And we end up with something like this. Another thing is we can rebuild this surface if you don't like this kind of structure, and just type in rebuild while selecting the surface, and you can actually change the point count. So I'll be happy with 10 by 10, and it actually shows you how many divisions it will have once you rebuild it. And you can kind of mess around with that until you get it sort of the way you want it. And okay, so now that we have this, what we could do is we could create a rectangular plane. So I'm just going to drag this out so I have access to it, and I can basically construct a kind of angled profile like this, which approximates this kind of edge here, and then it looks like there's another profile that goes from about here to here that is kind of angled like this, maybe even more radically so. I'll just try to bend it even more, maybe something like that. And then there's a flat surface that seems to be coming in from this profile up. So what we can do is we can use the vertical plane, and we can start off from these points here and kind of draw profile upwards like this. We can rotate it let's try to rotate in 3D. I just want to get this edge so it's vertical, something like this. And maximize this and actually scale it in one direction until this edge hits this edge. So I'm just going to do that as well. And the reason I want to do that is because I want to trim this surface against this surface and vice versa. So I want to do the following. And it doesn't want to trim. Okay, let's try to trim this against that. So that worked. And now I want to trim this surface against this surface. And it doesn't want to do that, unfortunately. So obviously that means somewhere they don't actually intersect. And probably the easiest way to do this is maybe to redraw this surface, actually. So what I'm going to do is to quickly kind of try to redraw this and try to trim it again. And there you have it. So that worked. And that probably needs to be a little bit smaller. So I'm just going to scale it down. Actually, I can't do that because it actually scales it. Scales this as well. Well, actually, what I can do is I can scale it like so, and then I can trim it again. So kind of cheated there, but oh well. And I just keep on going until I get the kind of shape that I want. So obviously it crinkles up again, and I try to approximate that here as well. Again, using the trim tool, and get rid of this extra bit, etc., etc. So you get the point. Now the kind of important bit of this geometry is that we have this kind of puncture going through the building, and I'm just going to switch to a reference that gives me an idea of what this thing looks like. Okay, so maybe something like this. So okay, so I can actually go into the right view. Let's scale this in one direction a little bit because it looks like it's a little bit too thin, maybe something like this. And I'm just going to hit on project here, and I'm going to try to kind of recreate this puncture in this view. Obviously, as I'm drawing this, it's going to be flat, but we're going to extrude it through this object, and then again use trim to kind of get rid of the surfaces that we want to get rid of. And so from the looks of things, this object has a geometry that kind of looks like this, and then there is let's see here, something like that maybe. And then for this tail here, and this is kind of very important, there are different types of curves that architects kind of use. So there are free form curves that are made using kind of free form tools, and then there are rationalized curves. So these you see that quite often in the works of Enrique Morales, where they're not actually free form curves, but they are curves that essentially have been straight, but they were filleted to give you an impression of kind of free form. So if we fillet these curves, come on, let's fillet this. Doesn't want to fillet. Let's just reduce the number. before. Sometimes if the radius is beyond the size of the line, it won't want to fill it. So this appears to be like a freeform curve. However, if we were to look at it, so I'm just going to draw a couple of circles like this. So this is a rationalized curve because the fillets approximate to these curves that are essentially joined by these other lines that create these interpolated fillets through them. So, and essentially this is a very important thing when you're trying to kind of model something, is to identify these correctly. So in this particular case, this curve appears to me like a filleted curve, so I might do something like this. I might actually ignore some of these and then fillet them in later rather than using a freeform NURBS curve. And sometimes it's kind of tricky to get the curvature quite right, so you might need to kind of fiddle around with it. So it's probably too much for this. Let's go with 6. So maybe even less. Something like this maybe. And then I'm just going to select all this stuff, join it together, and then offset it. Sorry, not offset surface, offset. So offset just does it for curves, offset surface does it for surfaces. And we need to offset it much less, let's say 4. Actually, you can see how much is going to offset it, so it's quite useful kind of visual reference. And of course, again, none of this is to scale, so just going to fill this in with a line, and then going to fill this in with another fillet, as it appears here. Fillets, and I probably need to bump this up to about 10, I would say. Not too much. So it's kind of very much a trial and error method, which I'm using. So that's kind of an approximation of what's happening with this aperture. Would be nice to kind of model it from an elevation, but I don't really have an immediate access to that. So if we go into the perspective, we can see that it's basically at the moment it's just a flat kind of shape. We can join it together and close it, and then extrude it through this facade. Oh, sorry, kept them. Again, extrude surface is for extruding surfaces, extrude curve is for extruding curves, and if you don't select the right one, Rhino just doesn't like it. I'm just going to extrude it about there. Actually, I don't want to extrude it as a solid. I want to extrude it as an open kind of shape. So I'm just going to deselect the solid here and extrude it like this. And now that I have that, I can actually trim out a lot of these objects here, like so, and then I can run this command again and trim the facade against this shape, like so. So we kind of begin to, looks like it doesn't properly intersect with some of these, which we're going to have to fix. Not quite sure why that is, actually. Let's just explode the shape into individual surfaces and then try to trim them individually. So there, individually they trim okay, it seems. and then use this, and this as a trimming target for this inside surface. And we can do that the same for all of these here. So I want to get rid of this bit and get rid of this bit. So there you have it. So we can now join them together, and we essentially have a pretty good kind of approximation of this very, very tricky facade situation. And again, you know, like, try to kind of think about it as you know, how do corners interact. So this side is pretty straightforward because the corner is essentially straight. So we can draw kind of vertical, let's draw a vertical surface, and it'll be completely straight. And but here it actually needs to be trimmed against this other side, right? So we need to kind of be considerate about how we intersect it, so we can actually trim it like this. So that's what the corner would look like, and that's what the corner kind of looks like here. Again, there's other complications because it appears that this surface actually extrudes a little bit and actually trims into this kind of edge, which then folds and doesn't quite meet this surface. But then again, like, these kinds of details are kind of very specific to the project, and this was just a quick exercise to demonstrate some of the basic techniques that you can apply to modeling some of these more complex geometries. So hopefully this was a useful kind of demonstration, and hopefully you'll be able to kind of apply some of these techniques to some of the more complex designs that you have in mind. So thanks for watching, and I'll see you next time.